Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, we are going to talk about molality. You know my friends, what is the molality? Why it is important? So, I will clear your concept in this video. Just continue with me and watch my each video. And I have uploaded many video previously on the concept of solutions, basic concept of solutions. So let us start the molality. It expresses the number of moles of solute dissolved per kg of the solvent. M is equal to moles of solute divided by kg of solvent. Because both moles and mass do not change with temperature. Molality, unlike molarity, is not temperature dependent. My friends, changing molarity to molality. You have this flow chart. If you know the density of the solution, we can calculate the molality from the molarity and vice versa. So you can see here volume of solutions, density, mass of solutions, moles of solute, molar mass, moles of solute, then molality and molarity. So this is the questions. A solution is made by dissolving 4.35 gram glucose C6H12OC in 25.0 milliliter or 25 milliliter of water at 25 degrees Celsius. Calculate the molality of glucose in the solution. Molar mass of glucose 180.2 gram per mole. So molecules 4.35 gram glucose multiplied by 1 mole of glucose divided by 180.2 grams C6H12O6, you will get 0.024 moles C6H12O6. Water has a density of 1 gram per liter. So the mass of the solvent is 25 ml multiplied by 100 gram per ml is equal to 25 grams is equal to 0.0250 gram kg. So molality of C6H12O6 is equal to 0.024 1 moles glucose divided by 0.0250 kg water is equal to 0.964 molarity. So normality, what is the normality? It expresses the number of grams equivalent of solute dissolved per liter of the solution. So N is equal to number of gram equivalent of solute divided by liter of solution. So normality, given weight divided by equivalent weight multiplied by 1 by volume of solution in liter. So equivalent weight, the number of parts by weight of that substance that will combine with 1 part by weight of replaceable H plus or OH minus, or number of positive charge on elements. So mole fractions, what is the meaning of mole fraction? The ratio of number of moles of that component to the total number of moles of all the component of the solution. So mole fraction say is equal to moles of A divided by total moles in the solution. The sum of the mole fractions of all components is always equal to unity. My friend, colligative properties. What is the colligative properties? Colligative properties are properties of a liquid that change when a solute is added. The magnitude of the change depends on the numbers of solute particles in the solution, not on the nature and size of the solute particle. The colligative properties arise from the attractive forces that are exerted by the solute on the solvent. Such attractive forces reduces the tendency of the solvent molecules to escape from the liquid as vapors, and vapors pressure of the solvent is therefore reduced by the presence of the solvent. My friend, following are the colligative properties of solution: lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. This is very important. Vapor pressure में कमी, boiling point का बढ़ जाना, dispersion of freezing point, and depression is कम हो जाना, and osmotic pressure. So lowering of vapor pressure. If any non-volatile and non-electrolyte solute is dissolved in the solvent, the escaping tendency of solvent molecules is reduced, and in turn vapor pressure is also reduced. And this is because the solvent molecules are hindered by the solute molecules, and so escaping tendency of the solvent molecule is reduced. Therefore, a less number of solvent molecules will be able to escape, and so less number of vapor will be formed, and ultimately the vapor pressure of the solvent is reduced. Greater the number of solute particles, greater will be the hindrance, thus lower is the vapor pressure. So my friends, therefore a less number of solvent molecules will be able to escape, and so less number of vapors will be formed, and ultimately the vapor pressure of the solvent is reduced. Greater the number of solute particles, greater will be the hindrance, thus lower is the vapor pressure. My friend, in case when any non-volatile and electrolyte is dissolved in the solvent, the lowering in vapor pressure will be abnormally high than that of the non-electrolyte. This is because the electrolyte dissociate into ions in the solution, so number of the particles will increase, and as a result lowering in vapor pressure will be also high. So elevation in boiling point. Greater the vapor pressure of a liquid, lower will be its boiling point. Similarly, lower the vapor pressure of liquid, higher will be its boiling point. So if any non-volatile and non-electrolyte solute is dissolved in the solvent, the escaping tendency of the solvent molecule is reduced, and in turn vapor pressure is also reduced, and ultimately its boiling point will be elevated. In case when any non-volatile and electrolyte is dissolved in the solvent, the lowering in vapor pressure will be abnormally high than that of the non-electrolyte. This is because the electrolyte dissociate into ions in the solution. So number of particles will increase, and as a result, lowering in vapor pressure will also high. Therefore, elevation in boiling point is also greater than that in case of non-electrolytes. My friends, normal boiling point process, a boiling process, extension of vapor pressure concept. Normal boiling point of substance, the rate of 1 atmospheric pressure. When solute is added, boiling point greater than normal boiling point. Boiling point is elevated when solute inhibits solvent from escaping. So elevation of boiling point expressed by boiling point elevation equation. You can see here the dotted line and solid line, and the phases change. So depletion in freezing point. My friends, the normal freezing point of solvent, pure liquid, is defined as the temperature at which solid and liquid forms of the solvent coexist in equilibrium at a fixed external pressure, commonly 1 atm, that is 660 mmHg. Pure water has freezing point at 0 degrees Celsius. At this equilibrium state, the solid and liquid forms of the solvent must have the same vapor pressure. If it is not so, the forms having the higher vapor pressure would change into that form having lower vapor pressure. Lowering vapor pressure of liquid after additions of solute has been discussed earlier. My friend, you can see here pressure and temperature. You can see the range, solid, gas and liquid. You can see the solid line and dotted line, and difference in del TF and difference in del TB. This is the boiling point, this is the freezing point. So the freezing point of solutions is the temperature at which solid forms of the pure solvent coexist in equilibrium with the solution at a fixed external pressure, commonly 1 atm. So as the vapor pressure of the solution is lower than that of the pure solvent, so it is obviously that the solid and solution can be coexist in equilibrium. This is because at equilibrium both states must have the same vapor pressure, and they can now coexist at some lowering temperature. New freezing point, where the solid and solutions have the same vapor pressure. That's why freezing point of the solvent will be lowered upon addition of solute. My friend, greater the number of particles, lower the vapor pressure and depression in freezing points. Now friend, osmotic pressure. Osmotic pressure, what is the diffusion? The movement of particles along the concentration gradient, that is the movement of particles from higher solute concentration to lower solute concentration. Osmosis is the spontaneous movement of water across a semi-permeable membrane from an area of the low solute concentration to area of high solute concentration. Or osmosis is the movement of solvent molecules from dilute solution to concentrated solution through a semi-permeable membrane. Or semi-permeable membrane is a type of membrane which permit only solvent molecules to pass through it. So what is osmotic pressure? the hydrostatic pressure that build up on the semipermeable membrane, which just stop the osmosis of pure solvent into the solution through the semipermeable membrane. So you can see the concentrated solution, you can see the dilute solution, you can see the semipermeable membrane. Then this the difference. So demonstration: tie a cellophane paper semi-membrane at the end of the thistle funnel and immerse it in the bath of pure water. Then the sugar solution in the funnel up to the Mars X and keep the apparatus for a few hours. After the level of sugar solution will rise from Mark X to Mark Y. This is due to the osmosis water from the water bath to sugar solution in the thistle funnel due to the movement of solvent molecules. After reaching at Mars Y, the movement of molecules will be stopped further. That was due to the hydrostatic pressure exerted by the column of the solution on the semimembrane, which prevent the entry of the pure solvent to the solution. So, if the concentration of solution will high, more solvent molecules will move the solution and the level of the column of the solution will rise higher and greater will be the pressure on the membrane, and ultimately greater will be the osmotic pressure and vice versa. My friend, osmotic pressure directly proportional to concentration of the solutions. So, osmosis and blood cells. A cell placed in an isotonic solution. The net movement of water in and out of cell 0 because the concentration of solute inside and outside the cell is the same. In the hypertonic solution, the concentration of solute outside the cell is greater than that inside. There is a net flow of water out of the cell, causing the cell to be dehydrated, shrink, and perhaps die. In a hypotonic solution, the concentration of solute outside of the cell is less than that inside, and there is a net flow of water into the cell, my friend, causing the cell to swell and perhaps the burst. So, ideal solutions. So, cohesive forces that exist between the two similar types of molecules, between the solute or between solvent. Adhesive forces that exist between different types of molecules, between the solute and solvent. So, solution in which the adhesive and cohesive force are same are known as ideal solution, a solution that obeys Raoult's law. So, what is the Raoult's law? Raoult's law states that temperature, the partial pressure of component in a liquid mixture is equal to the vapor pressure of that component in pure state multiplied by mole fraction of that component in the solution. This is the mathematical equation. So, mixture of volatile liquids. Both liquid evaporates and contribute to the vapor pressure. You can see solution A, solution B. Now mix together solution A and solution B. So Raoult's law, mixing two volatile liquids. Since both liquids are volatile and contribute to vapor, the total vapor pressure can be represented by using Dalton's law. So Pt is equal to Pa plus Pb. The vapor pressure from each component follow the Raoult's law. So mole fraction of A and mole fraction of B is equal to 1. So benzene and toluene. So consider two solvent volatile system. The vapor pressure from each component follows the Raoult's law. Benzene toluene's mixture. Recall that with only two component mole fractions of A and B, toluene and benzene is equal to 1. Benzene when they store and toluene. This is the mathematical equation. So you can see the graphical presentations, benzene and toluenes. Now, characteristic of an ideal solution. Ideal behavior is expected to be exhibited by the system which comprises of the chemical similar compound, because it is only in such system that the conditions of equal intermolecular forces between the components are likely to be satisfied. Example, solutions of ethyl alcohol, methyl alcohol, chloroform, bromoform, benzene and toluene. Ideal solution have zero enthalpy change. Heat is neither absorbed nor evolved during the solution's formation. The volume of the solution is exactly equal to the sum of the individual volumes of the components. My friends, what is non-ideal or real solutions? Solution in which cohesive and adhesive forces are not equal are known as non-ideal or real solution. Solution in which solute, solvent, and solute-solvent attractive force is not equal. Solution which don't obey Raoult's law. So deviation from Raoult's law. So negative deviation from Raoult's law. Real solutions which showed the negative deviation from Raoult's law are those solutions in which adhesive forces, solute solvent, are stronger than the cohesive forces, solute or solvents. And vapor